All right, greetings and welcome. We're talking about common logarithms. Those are logs of base 10, where the base is not written, but it is implied. And we're on page 620 doing some math, H-dubs, doing the quest from last night. We're looking at problem 16, where someone wanted to calculate 10 to this power. And check this out. If I know this fact, log of 6,500 is equal to 3.8129. That would mean, right, this is log base 10. If I was to write this in, say, exponential form, this is also implying that 10 to the 3.8129 is equal to 6,500. So for 16, if they asked us what that was, that's 6,500. I believe if I tried typing that into a calculator, using Antilog, or right 10 to the 3.8129, I get 6. If you used a calculator, you would have had 6499.80097. But using this fact that we'd already had, we were able to more accurately get the answer. Other questions from this one? 17. Mantissa. Let's see. So log of 0.065. That's the same as the log of... Well, I guess we already calculated log of 6.5 there, so I'm going to do this in scientific notation. 6.5 times 10 to the negative dose. Negative 2, right? And then using the log of a product, right, we can write that as the sum of two logs. So that's the same as log of 6.5 plus log of 10 to the negative 2. And log of 6.5 apparently is 0.8129 plus, this would be negative 2 when all is said and done. So if I wanted just the mantissa, this is the mantissa. Whereas the characteristic is negative 2. Right. Any other questions from that batch? Sure. Antilog. So to do that, let's see. Arg! I hate it when I click on the wrong software, and now it tries to load up, and it makes my computer slower. Oh, darn. Well, anyways, to calculate the antilog, you would actually hit second. All right, so I get the little arrow indicator, flashing arrow, blinking cursor. And above the log button, you get the little 10 to the x. So the antilog is literally 10 to the, and then what was they wanted antilog of 3.8129? 3.8129. Which is actually something I already calculated right there. They just were phrasing it in different ways, and I'd end up with the 6499 thing again. However, because of the facts that we had already gathered, right, I also could have said this means anti-ln. Nope, you don't know what anti-ln is yet. Antilog of 3.8129 equals 6,500, because antilog is the same as 10 to the. Same difference. Same thing. So, okay, close that window down. Shut it down. Here we go. Other questions? Blurries. What do we got? Coming into focus.
Just do one of the ones from 18 to 21.
Find the logarithm for each number rounded to 4 decimal places, and then state the mantissa in the characteristic. So no preference, just...
No preference.
I'm a fan of 23 myself. I think I just had a portion of the Inspector Gadget song get stuck in my head. So they had log of 0.0007, which I believe, I could write that inside. Actually, I'll do that in both forms. So let me just calculate that log, 0.0007, and I get that is approximately equal to negative 3.1549. Now, if I want to figure out what the mantissa is, it is not the 0.1549. All right, because of the fact that this number is negative. So what we're going to have to do is that little plus 10 and then minus 10 treachery. So I'm going to plus 10 it, and I will get 6.8450. Oh, that's 1. I'm a fan of 4 decimal places. Minus 10. So this is the same as 0.8451 plus 6 minus 10, right? If I just move that little 6 part over, and 6 minus 10 is, if I'm not mistaken, negative 4 because of the maths. And so therefore, this is the mantissa. And this is the Charizard. So the other way you could have done this, alternate universe, if I wrote this in scientific notation, this would have been the same as log of 7 times 10 to the negative 3. So that's log 7 plus log 10 to the negative 3. Log of 7, question, is log 7 going to be bigger than 1 or less than 1? What does log 7 ask us? 10 to what power is 7? 10 to the first power would be 10. So it's got to be 10 to some number less than 1 in order for it to be 7. All right. So just kind of I want you to just start thinking about like what that ballpark would be. And I believe if I plug that in, I'll get this 0.8451. But I'll plug it in for reals here. Log 7, I get, in fact, 0.8451 plus, and then log of 10 to the negative 3, log of 10 base 10. Sorry, log of base 10 of 10 is 1, because 10 to the first power is 10, and then take the negative 3 out front. And you can see that it jumps out a little bit quicker that way. So yeah, the goal is that you typically will have your mantissa be positive.
Why are the characteristics different?
Oh, what did I do? Ay, mis dedos de los pies.
Is it supposed to be negative 4?
What did I do? Did someone spot it? This is... Oh, this is a negative 4. I did my scientific notation wrong. Shame on me, Mr. Waddy. Shame on me. I even have my little rule that I use to remember scientific notation, and I didn't use it right. I forgot my own rule. Good catch. Thank you, friends. Yeah, so my rule for scientific notation is if you include the 0 in front of the decimal point, then the number of zeros will be your negative exponent for scientific notation. But I ended up discounting these zeros, not all 4. So there's my problem. Good catch, team. Other questions? Did I assign some crazy one? No, I didn't yet. That's tonight.
Can you do 21?
Sure. 21. Paste. So, log of 6.377, if I just type that right into a calculator, 6.377, which, by the way, I think if you search like internet calculator or Web 2.0 calculator or something like that, you can find a calculator on the internet that will do logarithms for you, and among other things. And I get 0.8046. So it turns out that the mantissa here is this part, and the characteristic is 0. So
How do you figure that out? How did you get that?
well, I just plugged this in the calculator, and the characteristic is typically the integer portion, like the number to the left of the decimal. And in this case, it ends up not working out. And the mantissa is the decimal portion. Let's see, even if I wrote this in scientific notation, let's consider it from that perspective. That would have been log of 6.377 times 10 to the 0th power, because the decimal is already in the right spot. So that would have just equaled log of 6.377 plus log of 10 to the 0. And I would have gotten 0.8046 plus 0, indicating that as well. So that is a good question, making sure we understand what the mantissa is. So, it's 11.5-minute video. Not bad. Bye-bye, Internet.